Okay, guys, number 45 and 2.6. I'm a little annoyed right now because I just did this whole problem and recorded it and made one stupid little error right at the end and screwed it up, and I'm not smart enough to know how to edit a video, so I got to do the whole thing again. All right, let's try this again. The first weird thing about this problem is that we're taking the sine of a double angle here, 2h. So we're going to use a little identity that you guys, I'm sure you learned last year in pre-calc, and you maybe even had to have it memorized last year. You definitely don't need to have it memorized for me here this year, guys, but here's one we can go back, and of course you could Google this if you forgot. The sine of 2h, or the sine of 2 times any angle, can be rewritten, guys, as 2 times the sine of the singular angle, h, multiplied by the cosine of the same angle, h, as well. So not something you guys have to have memorized, but it is something that I'm hoping you kind of go, oh yeah, we learned something like that from last year. Okay, what's coming next then? You can't do anything with 1 minus cosine of h. It's just kind of ugly, but I'm hoping you recognize this from a previous problem. I know I made a video on this, I think maybe on 22 or 24 on this section here, where when you've got that binomial of 1 minus cosine of h, what we're going to do is we are going to multiply that by its conjugate, 1 plus the cosine of h. And if you don't know why, stick with me. You'll see why in just a second. The denominator had an h squared in it, and of course I need to multiply that denominator by the 1 plus cosine of h as well. Okay. So what have we accomplished right there? I'm going to switch colors on you guys to green here and save myself a little bit of room. This product right here of these two conjugate binomials, when you do FOIL, you're going to end up with 1 minus, and then it's going to be cosine squared of h. The outer and the inner products cancel out. So okay, that all simplifies to 1 minus cosine squared of h. And I'm hoping you remember from your trigonometric identities, 1 minus cosine squared of an angle is just sine squared of that same angle. So everything that was here in these brackets in the numerator now simplifies to just plain old sine squared of h. So what good does that do us? Well, I want to remind you guys that at the beginning of our notes on section 2.6, I told you that there was really only one trigonometric limit that you guys had to have memorized, and that was the limit as h approaches 0 of sine of h over h, or sine of any angle over itself. That limit is equal to 1, and if you can, you try to whittle down and manipulate any expression you've been given to try to be expressed in terms of that ratio right there. Well, if you look at our numerator, guys, we have got a sine of h here, and then 2 sines of h right here, and then 2 h's down on the bottom. So here's what we're going to do. I'm going to make this one here a sine of h over h, and then I'm going to multiply that by another sine of h over h. So let me switch to red now. I just took care of the sine squared of h. That was my first sine of h times my second sine of h, and the h squared in the denominator, that's been taken care of as well. That's the 2 h's down underneath there. So what's left then? In the numerator here, we still have a 2. There's a sine of h out in front that I didn't mess with, and a cosine of h there as well. And down in the denominator, we still have this binomial of 1 plus cosine of h. And I am pretty sure, guys, that takes care of everything from the original fraction. The 2 has been taken care of, the sine of h, the cosine of h, the sine squared of h up here. Yep, we did that here and here. And in the bottom, h squared, that was this times this, and then the 1 plus cosine of h is this right here. Okay, we're in good shape then, guys. Now we're ready to use the product law for limits that says the limit of a product is equal to the product of the individual limits. So we're going to apply this limit as h approaches 0 to all 3 of these individual factors, and then just multiply those 3 limits together. And this time, I'll try not to screw it up. So here we go. The limit as h approaches 0 of sine of h over h, that's an identity we need to have memorized. That's a 1. Times, well, here's the exact same thing again. So there's a 1. And now, this third one gets a little bit more complicated right here. We have a 2 in our numerator, times, all right, we're going to let h actually become 0 now. And the sine of 0 is 0, and the cosine of 0 is going to be 1. All over, and here's kind of the moment of truth to see if this is going to work. We do not want to end up with 0 in the denominator, and we don't. This is a 1 plus, and the cosine of 0 is 1. Okay, so now guys, if you notice, this is a big fat multiplication problem. 1 times this whole mess. And here's what I missed last time. The presence of that 0 right there means that this entire third fraction is going to end up as 0 over 2, which is just 0. And hey, Mr. Fontana, 1 times 0 is 0, not 1, like I wrote the first time around. And that, everybody, is the correct answer to section 2.6, problem number 45.